Hello everyone. In this video, we'll be just seeing about what is meant by memory management. So why we need a memory management? So it is one of the important topics we'll be covering in your operating systems. Why? Because your memory management is one of the important functionality of your operating systems, which will be handling your or managing your primary memory and will be forth back between your main memory and your disk during the execution. So each your memory will be keep tracking of each and every memory location, whether it is allocated to some process or not. It is whether it free. If it is a free, it can be allocated within some memory. If it is not, it is unallocated. It will be corresponding updating the status to the memory. So these are the some memory addresses and descriptions. So there are three memories addresses are there. Symbolic addresses, relative addresses, and physical addresses. Symbolic addresses means which are used in your source code. So variable names, constant, and instruction labels. So these are the some basic elements used in your symbolic address space. Next comes your relative address space. These are used at the time of compilation. Here, your compiler converts your symbolic addresses into your relative addresses. So next comes to your physical addresses. Here, the loader generates these addresses when execution time of your when is your program is get executed and also loaded into your main memory. So next comes physical address and virtual addresses are compiled at the same time by using some low time address binding schemes, and virtual and physical address are differs in the execution time address bidding schemes. So next, so these are the some common differences between your static loading and the dynamic loading. So the definition is that all modules are loaded before execution. Here the modules are only loaded during the execution. When it happens means only compile time, here runtime. Here flexibility is fixed, but here fixable. Executable size, it is large and it is small here. Speed is faster execution, but it's slightly slower here. Memory usage is higher and it is efficient. Dependency, no external dependency or runtime, but depends upon the external library as the runtime. Error detection found at compile time. Error occurs may only at the runtime. So here example is your static linking in C, C++. Here it is dynamic linking. So what is the real life analogy for the static and dynamic is buying all book before studying. Here borrowing books only when it is needed. So next, so these are the major difference. So we had covered in the previous one. And next comes to your memory allocations. So memory allocation is like same like your memory. It is allocating of your memory to each and every process which is in your computer. So whether it can be allocated continuously or non-continuously. So here based upon this, it is converted into two types: contiguous memory allocation and non-contiguous memory allocations. So this is a architecture view of your memory management technique. That is two types like contiguous memory allocation and non-contiguous memory allocation. So in contiguous memory allocation, we will see about single contiguous allocation and partition allocation. In non-contiguous memory allocation, we'll be seeing about paged memory management, segmented memory management, and segmented memory management with pagings. Next one is your contiguous memory allocation. So what does a contiguous means? It is allocates the process in the single continuous block of memory. So every process will be holder to the entire process. So it will be allocating a process without any interruption. If you see the below diagram, there are three processes are there, P1, P2, P3, using the contiguous memory allocation. Here, the P1 will be allocated with three blocks and P2 is allocated with two blocks and P3 is allocated with only one block of memory. So there are some gaps in your allocated memory, which is called at F4 and the F7. So in contiguous memory allocation, there are two types, that is your fixed partitioning and the dynamic partition. Either way, the fixed is called as static and dynamic is called as a variable. Fixed partitioning means like your main memory is like divided into some partition of fixed sizes. Each partition will be holding only one accurate processes. So when new process comes into the memory, it will be allocated to some partition of fixed size. So if it is larger of size, the remaining will be wasted. If it is a larger, it cannot be hold the memory. So here in this way, internal fragmentation is occurring. Here if you see the process P1, P2, P4 are there. So after P4, there occurs a internal fragmentation in the fixed partitioning. So next come the dynamic partitioning. So vice versa of your fixed partitioning. There you will go with fixed size, but you will be taking your dividing your partition into varying sizes to the each process allocated in your systems. So here the external fragmentation takes place in the case of your dynamic partitioning. So up to this, I'm just completing my video. So later on, we will be just seeing about the other things